With this video, I want to introduce the idea of a Lewis symbol, or sometimes you'll hear me say Lewis dot symbol. And the dot just represents the electrons, the valence electrons that are for a given element. Okay, so remember these are the valence electrons from chapter 6. And basically they're going to tell us, what electrons can react in a molecule. And first off, just look at the pattern in terms of the number of electrons around each element. And also notice what we're looking at. These are actually the representative elements. So let me go to the periodic table real quick. Right, what we were just looking at is this block here. So notice we're ignoring the transition metals with this. And the number of dots actually correspond to the label that you see on the periodic table here. 1, 2, 3. We're basically just counting up as we go across the periodic table and ignoring helium. This last family is going to have 8 valence electrons. You're really not going to see neon, any examples, but you may see krypton, argon, and xenon in a few examples coming up for this chapter. Okay, so those are electrons we're going to use. Okay, and then notice how they're set up here. Like for example, let me just use carbon. It's got 4 individual electrons around it versus nitrogen that has one set that's paired up there. Let's just sort of play around with those two for a moment. And the way I want to do this, I actually want to hit the most important type of reaction first here. So these are two, the simplest carbon-containing compound and the simplest nitrogen-containing compound. This is ammonia. This is methane. And there actually is one missing from this row. There's hydrogen, right? It's still in that same row. It's got 1 electron around it. That's useful to note, right? This is the periodic trend for the valence electron count, right? So not only does carbon have the 4 electrons around it, but silicon does, and germanium does, and that's the same for all families. Like the oxygen family's got 6 electrons around it. They all have it all the way down. Okay, and there's a hydrogen example. Let's just see how we actually use the Lewis dot symbol. So I want to draw the Lewis structure, or the molecular formula sometimes, or the structural formula, sorry. Here I just want to draw what we call the Lewis structure. And I'm going to do this kind of quickly. There'll be other videos to show you how to do it with more advanced topics a little bit later on. Basically what we're going to see is we're going to have a central atom. In this case it's going to be carbon. And I'm going to lay the dots out like I see it, or the electrons like I see it. And then I'm simply going to place the hydrogen around that central atom in such a way to where, well, basically what's going to happen is that when you have 2 single electrons lining up from one atom to another, it forms a covalent bond. Right, and this is where the electrons are shared between the 2 elements there. And what do you know? We have 4 single bonds around methane. That's its Lewis structure, or structural formula. Again, sometimes that's used. Lewis structure is what you're going to hear over and over again for Gen Chem 1. Let's do the same thing for ammonia here. Okay. Right, we have that pattern. I'm just copying right here. Oh, please note, one thing to note is that I touched that twice. There should just be 2 dots there. It does not matter, what the relative positions are for like the pair of electrons versus the lone electrons. You can rotate these as you need it. Okay. And actually, in a later example, you can actually move them around as you need it, but not for right now. Same thing as before. Why are there 3 hydrogens attached to the nitrogen? Well, It's because there's 3 single electrons in the Lewis dot symbol that allows this thing to then form covalent bonds here, right? And that's it. That's the Lewis structure for ammonia. Let's do one more here. Let's do diatomic nitrogen, okay? And I'm going to basically approach it the same way as I did before. This is not the most efficient way to do it, but it'll work. Okay. I only have 2 nitrogens. They're going to be connected together. Great. Well, I can see one covalent bond here where these 2 are going to connect together. That's fine. But notice that the way the Lewis dot symbol is laid out, these other electrons just don't line up like they need to. Okay. Well, what you can do actually is that you can really move these electrons around as needed. Like these 2 can move in to form a new bond. These 2 can move over to form a new bond. Basically, what you're going to see is that for the vast majority of our examples, okay, until told otherwise, all electrons will be paired up. And that's either in the form of, single dots, right? That's lone electron pairs. Or you'll see it as a line, which, right, is a covalent bond. So basically what I'm saying is that if you see single dots around a molecule, bring them together. Right? There's a few examples that will be different, but that's not for us to worry about now. Now, this structure is kind of messy. Let me redraw it in a more traditional fashion. Still has their triple bond in the middle. Typically, the lone pair electrons, we move them on this side. Honestly, it doesn't matter when you're doing the work for me. If you get them in not the perfect spot, I don't care. It's fine. The main thing I would be looking for like example, the nitrogen here, is that you've used all those dots. You've used up, i.e. you've used up all the valence electrons. Everything's paired up, and that's it. There's later videos, we'll talk about octet rules and stuff like that. Basically, the vast majority of the atoms will have 8 electrons around them. A few exceptions, but again, that's for a later video. Now, before I leave though, what I've been doing so far, these are molecular compounds. And that's really what we're focusing on Chapter 8. We actually introduced this back in Chapter 2 briefly. But Chapter 8 also deals just a little bit with ionic substances, ionic compounds. Right, an ionic compound would be, where you have a cation and an anion come together. Like for example, and we'll do sodium chloride. You can actually use the Lewis dot symbols, and you don't even need the plus there. It's probably going to get in the way. It doesn't really matter. Oops. So chlorine, it's got 7 valence electrons. If I look at the pattern, not there. If I look at the pattern, there we go. Right, 3 of them are paired up, and then 1 is unpaired. A lot of times when you're laying out the electrons, because it has 7 valence electrons, you're going to lay it around the Lewis dot symbol, and a lot of times what you say is that you start just putting 1 at a time around each position, and then you start pairing up until you run out of electrons. It's kind of in the spirit of orbital diagrams, slightly. It's not an orbital diagram, but it's kind of in that spirit. And what you wind up with, if you do that pattern for all of these, like for example, the oxygen family has 6 electrons, so 1, 2, one at a time, and then I've run out, and that's giving me here two points here where it reacts. Anyway, so there's chlorine, and notice what happens here is that there's 2 points here where there's single electrons. Now, and in an ionic compound, the thing you got to remember is that electrons are not shared. Okay, the electrons are transferred between the two elements. And one way to show it is something like that, where now what happens is that, right, we learned back in chapter 2 that if something loses an electron, it takes on a positive charge. In this case, it loses one electron, so it has a +1. And then the thing that gains the electron, well, it takes on a negative charge. And in this case, since chlorine gained one electron, then chloride, using proper nomenclature, would have a negative charge with it. And for this chapter in particular, you actually put the dots around all the dots around the ion there. It's not always done, but for this chapter, typically you do see that. And there it is. There's that positive and negative that we know about for the salt formula. Just another one real quick. Magnesium's in the second family. It's got 2 electrons. And then let's say, what does it do with bromine? Bromine's got 7 electrons around it. Now, one thing to keep in mind is that something we learned back in chapter 2 is that when these 2 families react together, it does something like that. So actually I need to bring 2 bromines in. And in some ways what we're using here is actually showing, it's an explanation about why they pair up in this 1 to 2 fashion. And it's going to get rid of one of these electrons to that guy, and then the second electron to that one. And then what we have would be magnesium, which again, we saw this in chapter 2, right? We see that. And for this chapter, chapter 8, I'll go and add all the electrons around the bromide ions. Okay, so just a brief little intro about Lewis dot symbols and how they're used to account for both, right, ionic compounds, where electrons are transferred, versus molecular compounds, where electrons are shared. Next video, you'll see a more formal way of drawing Lewis structures for molecular compounds. We really won't do much more with ionic substances than what you saw here.